This is Mr. Wright. Today we are going to be learning about special properties of right triangles. That includes the Pythagorean Theorem. So the first thing you have to know is how do we identify the different sides of a right triangle. So the two sides of a right triangle that make up the right angle, this is my right angle. These two sides are called the legs of the right triangle. And then the side that's crossing the right angle. So from my right angle, if I just draw an arrow kind of in the corner, then that's going to always point to the hypotenuse. A couple things, so that's always across from the right angle. The hypotenuse is also the longest side in a right triangle. So it's really important when we do the Pythagorean theorem that we can identify the difference between the legs of the triangle versus the hypotenuse. So here are a couple of examples. So what I like to do is just identify the hypotenuse first. So across from the right angle, that's my hypotenuse. The other two are going to be legs. Legs each of the hypotenuse. Hypotenuse is the leg. So you guys notice the right triangle can be like flipped around. So the hypotenuse can be on like different sides. So it's really important that we are able to identify what side is the hypotenuse. This little trick that makes it easy, just always start at the right angle, draw an arrow from there, what's the hypotenuse? Okay, so we're going to be working with right triangles, and just remember right triangles have a right angle. So the Pythagorean theorem. This states that a squared plus b squared equals c squared. So a and b are going to be the legs of the right triangle. So when we're doing the Pythagorean theorem, it doesn't matter which leg is a and which one's b, they're interchangeable. But c always has to be the hypotenuse. So that's why we have to identify the hypotenuse, because that has to be the c value. So when we're doing the Pythagorean theorem, a squared plus b squared equals c squared. The first thing you want to do is just identify the three sides, a, b, and c. So you may want to start with the c, because that's the hypotenuse. Then the other two sides are a and b, it doesn't matter which one's a and which one's b. So after you label them, you're going to plug them into the Pythagorean theorem. So I'm going to replace the a with 5 squared, plus b is 12 squared, equals c is x squared. After that, we're just evaluating that. So that I just figure out, like, what does that equal? 5 squared is 25. 12 squared is 144. Add those together, I get 169. Then do the square root of that. So whenever, like, you're solving an equation to undo x squared, you have to do the square root, and you get 13 equals x. So when you do the square root of x squared, they just cancel each other out. So you do with x, so there you don't type anything into your calculator. The only thing you want to type into your calculator is the square root of 169, you get 13. Let's just do one more example. So I'm going to label my three sides. Across from the right angle is my hypotenuse, that's C. The other two are A and B, it doesn't matter which one's which. I'm just going to plug in the three numbers. 20 squared plus 15 squared equals y squared. And we evaluate it, you solve it. 400 plus 225 equals y squared. Add those together. Then last step, you do the square root, you get y by itself. You get 25 equals y. We talked about how the hypotenuse always has to be the biggest number. So if I got 25, you just easy check is 25 bigger than the two legs, 15 to 20? It is, so that makes sense. If I ended up with a number that was like smaller than the leg values, then it wouldn't make sense, and I would have done something wrong. Another use, like if you have like a square or a rectangle, when you draw the diagonal across these shapes, you create a right triangle. So that would be another situation where you can use the Pythagorean theorem, where you're kind of just like looking at half of the shape and then with the Pythagorean theorem. So in these two examples, we solve for the hypotenuse. These next two examples, if you notice, now there's a number on the hypotenuse, so that's my C, and one of the legs is the C. So we're going to follow that same process. We're going to plug in those three values into the Pythagorean theorem. And now when we solve it, it's just going to look a little bit different. So we still evaluate, like when you square the numbers and figure out what those equal. So 64 plus x squared equals 280. Alright, so now to get the x squared by itself, I have to get rid of the 64, so I'm going to subtract 64 on both sides. So x squared equals 225. And then the last step is the same, where you do the square root, and I get x equals 15. So now because we're solving for a leg, then that number should be less than the hypotenuse, because the hypotenuse has to be the base number. So because 15 is less than 17, that makes sense. This one, identify our hypotenuse, that's C. The others for A and B. 15 squared plus x squared equals 24 squared. Square everything. 225 plus x squared equals 576 minus 225. And up with x squared equals 351. And then you would have to do the square root of that, put that into your calculator, and get your answer. This is going to be a decimal, so just type it in, figure out what it equals.